Welcome to this video on triangles. In this video, I'm going to show you how to solve two geometric problems using the congruency proofs that we looked at in the last two videos. Now, looking at this first problem here, it says prove that triangle MNO is congruent with triangle PQO, and hence find the value of x. So find this unknown. So first thing, look at the cursor. Triangle MNO, so MNO, this triangle on the left here, and then triangle PQO, so the triangle on the right. The question has told us that they're congruent and we first have to prove it. After that, we can find the value of x. So the first thing we do when we go for these problems is we first state the name of both triangles. So we're going to go triangles MNO and triangles PQO. So even though it looks like a wasted line, we always state the two triangles that we're going to be working with. Now the next step we do in working with these problems is we list all of the given geometric properties that we can see. So the first thing we can see is, well, I can see a pair of equal angles. So notice that these two angles in here, these two angles are going to be equal because they are vertically opposite one another. So what I can see is that angle POQ, in fact I'll change it around, I'll go angle NOM, angle NOM is equal to angle POQ. And the reason I know they're equal is because they are vertically opposite. Alright, cool. Now the next thing that I can see, so the next angle I can deduce is angle MNO and angle PQO. I know that these two angles are going to be equal to one another. Now the reason I know that these two angles are equal is because they are alternate angles. Notice that we've got the parallel lines here. And notice the configuration of the angles. So both of these angles are subtended by this common line here, N and Q. And because of the way they're intersecting, so they are here and here, they're on alternating sides. And based on the properties of alternating angles, we know therefore that angles MNO and angle PQO are going to be equal based on the alternate sides property. Now the final property we need to look at, or the final quantity, is notice side MO and side PO. Both of these sides are equal to 7 centimeters. So what we can say is that they're equal and it is given. Now have a look at what we've got. We've got two angles and we've got a side. Now if we go up to here, so notice two angles and a side, what we can say is that the two triangles are congruent with one another based on the angle side property. So we can say therefore triangle MNO is congruent with triangle PQO, and they're congruent using angle side. Now next step is, because we know that both of these triangles are congruent, what that means is that all of the sides in the triangle are going to be, they're going to have counterparts. So notice that this 7 here, its counterpart is over here, and this side here, its counterpart's going to be there, so that's 5 centimeters. And this side over here, it's 6.5, which should be the counterpart to x. So therefore, what we can deduce is that NM is equal to x. And therefore, well, actually no, we won't go that route. We'll go side NM is equal to side PQ. And therefore, side NM is also known as x. And side PQ is known as, or is, a quantity of 6.5 centimeters. So therefore, the value of x is 6.5 centimeters. So this is an example of how you would be setting out your working out when you're solving these geometric problems. Alright, let's zoom down to our next problem. So it's a 4-part problem. We've got this triangle over here, and it says triangle ABC is a triangle with side AB equal to side AC. Side AD is perpendicular to side BC. Prove that angle ABC is equal to angle ACB. Alright, now we're going to do this in 4 steps, similar to what we did just moments earlier. The first thing we're going to do is state the 2 triangles that we're interested in. Then we're going to list all of the common quantities. After that, we're going to state whether they're congruent or not. And then finally, we'll state whether ABC is equal to ACB or not. So first things first, we're working with 2 triangles in particular. We're working with triangle ABC, or ABD, I should say, ABD, and we're working with triangle ACD. Now, next step is we need to list all of the properties. Now, the first property we can look at is angle ADB. So ADB, this guy over here. Now, angle ADB, we know for a fact that it's going to be equal to angle ADC, and they're both going to be equal to 90 degrees. How do we know that? Well, notice that they share a common line, and the way in which they work out, because one of them is 90 degrees, then the other one also has to be 90 degrees. So we can get away with just saying that that's given because it's so obvious. Okay, now the next one is we're going to go AB and AC. So side AB is equal to side AD. Oops, A. And that's also given. Why is it given? Well, because it's got the markings there. It's told us that they're equal. And the final quantity we're interested in is side AD. It's common. So it's common between both of these triangles. Again, that's given. So this side here, it's shared amongst both of the triangles. Alright, so what do we got? We've got a right angle triangle, and we've got 2 equal sides, and we've also got a right angle. So what we find is that triangles that's a disgusting ABC is congruent with triangle ACD, and we did that using the right angled triangle and side proof. Now, because we know both of the triangles are congruent, what we can get away with saying is that therefore A, or angle ABC, must be equal to angle ACB. And the reason it has to be that is because, well, if the triangles are congruent, they're the matching angles. So angle ABC and ACB, they must be equal because they're matching angles in congruent triangles. Okay, so that's part A out of the way. Now part B, what type of triangle is triangle ABC? Explain your answer. Now looking at this triangle here, ABC, we'll have a look at it. There's 2 matching sides and one side where it's unlikely to be matching with the other 2. What we can say is that this triangle is an isosceles. And because the reason it's an isosceles triangle is simply because angles or sides AB and AC are equal. So that's part B, done and dusted pretty quick. We should label these. Part A. What triangle property have you just proved? Okay, so a bit of an out there question. What property have we just proved? We'll think about it. Triangle ABC is an isosceles because AB is equal to AC. We proved that these 2 triangles here, they're congruent because there's a common right angle in here. And furthermore, the 2 sides are equal. So what that's suggestive of is that in an isosceles triangle, the angle formed in here and the angle formed in here, they also have to be equal. So angles ABC and angles ACB are equal. Alright, and finally for D, show that BD is equal to DC. So BD and DC. And of course, well, they have to be equal because we're dealing with congruent triangles here. So we can say that matching sides of congruent triangles. Therefore, side BD is equal to side CD. Too easy.